So today we begin looking at graphing quadratic functions. Quadratic functions in general is a really significant topic for us in Algebra 2, and for that matter, beyond Algebra 2. We're going to graph quadratic functions, which we did in Algebra 1, so it's been done before. And we're also going to find and interpret maximum and minimum values of a quadratic function. Because a quadratic function typically graphs as a parabola, or as a parabola opens up or down, there is a minimum or a maximum point. So there is a minimum value as far as the y values go, or there's a maximum value as far as the y values go. So we'll be seeing that as we go along here. So we know that quadratic functions can be written in this form: ax squared plus bx plus c, but a cannot be 0. That's the qualifier here. You may remember in linear, we had the ax plus by equals c, and if it was written in standard form, we had to be integers and all that. Well, that's not a criteria here. It doesn't have to have those particular pieces, but a can't be 0, because if a is 0, then there's no x squared, and it's linear all of a sudden. So that, by definition, is how it works. So we call this first term the quadratic term, because it's the one with the square. We call the second term the linear term, because it's the one that we would use, like I said, in linear equations, x to the first degree. And then this third term is just a number, so we call it the constant term, because it doesn't vary. We'll discuss the axis of symmetry. If I could go back up here, even though my drawings are not cute, the axis of symmetry is going to come right down the middle. It is always going to be a vertical line for these parabolas, because they open up, open down, be a vertical line. Axis of symmetry means if we fold the graph on that line, it maps over to the other side. And we'll see some stuff in a few minutes about how that works and some things that it does. And then the vertex is that point where we find our maximum and minimum we talked about earlier. And it is the place either here on the axis of symmetry, right at the bottom of the vertex, or here on the axis of symmetry, right at the top of the parabola. So one way to do this, of course, is the old-fashioned way of plotting points. Now, this is quadratic. We can see that by its style. And when we put numbers in here, like -3, I'm just going to make some real quick notes. -3 squared is a +9. Any number squared is a positive. Any real number squared. And then that is going to be -9, and it's -1. So our answer is -1. So we can put the -3, -1 on our graph. Next we'll do the 2, the -2. And so -2 squared is 4. And you put -2 here, you get -6, and then -1. So that would be -3. So -2, -3. Next we do the 1. So -1 squared minus 3 times a -1, and we get -3 again. So -1, -3. Put in the 0, of course, then that's 0, so we get -1. And then we put in 1. 1 squared, 3 times 1, and we get 3. So 1, 3. So just a quick, since we kind of know how this thing was supposed to look anyway, as a parabola, that's how you graph using a table of values. Now, a couple things I'll point out to you here. First of all, somewhere down here is the vertex. It is the minimum point. Through the vertex is the axis of symmetry. I can't swear and guarantee it just right this second, but I'm pretty sure this is of the form, or this is the x equal -1.5. I think it's halfway between 1 and 2 here. And I'll point this out to you also, that look how these things match. I'm pretty sure then that if I put in -4, I'm going to get a +3. You want to look and see? Put in -4. -4 squared is 16. Put in -4, I get -12. minus 1. What is 16 minus 12? 4 minus 1, 3. It's cool how that works, but that's because of the axis of symmetry, being able to fold and see you get a point here, you got a point there. When you're looking at the y's, you're going to see matchy, 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 matchy across the entirety of the parabola. So once you kind of get an idea of how these work, it's just the answer. Once you get an idea of how these work, then it's not too hard to plow through them. It says which graph is the graph. The very first thing I would do is find out what's going on at 0, because you see on the axis, what's going on at 0? What's the y-intercept? Okay, so that would be 0. If x is 0, that's 0, that's 0, 2. So 0, 2. So here's 0, 2, not on the graph. Here's 0, 2, not on the graph. Here's 0, 2, on the graph. Here's 0, 2, not on the graph. The answer is C. Now that's pretty lazy. You know, I didn't do any other points. I did 1 point, and I was able to see that. If I wanted to graph this, and I didn't already have a picture, and I had other things going on here, then I could do what I did a moment ago, and I could create other values, you know, do like a -1 and a +2, and I could see what that would give me, see how that would work, or maybe I should have done a -2 and a +1, but I could see how that would work. For example, let's do the -2 just for the fun of it. So -2 squared is 4, it'd be 8. Put in -2. And 8 minus 6 plus 2 is 4. So, oops, I'm doing this one, 4. So you see -2, 4. So I confirmed another point. Just see how that works. But you can make up points all day long. You just really can. So it gives us then this picture that I have already kind of given you, because I told you if it's an open up parabola, there's a vertex, axis symmetry plows through it. We've already talked about the x-intercept. We did not discuss the reflection of the y-intercept, or the y-intercept here, reflection of the y-intercept. But I do want to draw your attention to this significant big deal right here, and that is that the axis of symmetry is x equal -b over 2a, okay? Now, let's go back to this one. The axis of symmetry, pick me another flavor here. The axis of symmetry is -b over 2a. Remember here, a is 1, because it's the coefficient of the quadratic term. B is 3, because it's the coefficient of the linear term, and C is -1. So let's take that stuff and plug it in here. Opposite of B would be -3, and 2 times A would be 2. So it's a -3/2 or -1.5. And I think maybe I predicted that just by looking at the graph. But that's how you can find the axis of symmetry. And it's also how, let me show you. That's how you find the axis of symmetry. That's also how you find out the x-coordinate of the vertex, because the x-coordinate of the vertex has to be on the axis of symmetry, so it has to have the same x as the x, or the axis of symmetry, which is x equals some number. Okay, we'll plow through that. We'll get there. So let's consider the quadratic function, da 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 da. By the way, this is not written in cube form. We would write it as x squared minus 4x plus 2. As far as the ABC, looking at it that way. So let's find the y-intercept, the equation of the axis of symmetry, and the x-coordinate of the vertex. Well, first of all, let's talk about the y-intercept. And in times past, we said every y-intercept that ever lived, the x is 0. It just is. So if x is 0, that's 0, that's 0, 2. Done. That's the y-intercept. Next, we have the equation of the axis of symmetry. Well, the equation for the axis of symmetry is a -b over 2a. When we look at this, now that I've got it written in better form, a is 1, right? A is 1. B is -4. And C is 2, although I don't need the C to do this work. I'm just making that observation. So the opposite of B, since B is -4, the opposite of B is +4. And 2 times A is 2 times 1. so the axis of symmetry is 2. That's also the x-coordinate of the vertex. So wherever the vertex is, it's at 2 something something. How could I find the something something? I'll put the 2 in here and find out. Find out what happens when x is 2. That'd be 4. Let me put that somewhere. It'd be 4, 2, b minus 8, plus 2. So 4 minus 8 plus 2 is a negative 2. So watch. I did those 3 things. In fact, I did this extra piece to the vertex. So they didn't ask me to find the whole vertex, but I did. They said just find the x-coordinate. I already knew it because that has to be there. But watch what happens here. This is the neat thing. So 0, 2, we know it has to pass through this point. We know that it has to have a vertex of 2, negative 2, and an axis of symmetry at 2. So I just graphed it. That's how that works. And that's the neat thing that I hope you can see and appreciate as we go along, is how all these things fit together, and how the more of this stuff you learn about, the easier the whole picture becomes, because you see these interconnections. You see how things relate. So they didn't ask me to graph it there, but I went ahead and graphed it. They rewrote theirs. They talked about the y-intercept being 2. They identified the A, B, and the C. They did the axis symmetry is 2. They said the x-coordinate of the vertex is 2. They did all of that. Now it says make a table of values that includes the vertex. So I didn't do that, but I'm going to do that because I want to walk you through this piece of this work. So we already said the axis symmetry is at 2 something. We know that it was 2, negative 2. But they want us to make a table of values that includes the vertex. So I'm going to start at 2, I'm going to go down a couple, and I'm going to go up a couple. Okay, I have a reason for this. I'll show it to you. So we've already done the 2, so we know we already did the 0, right? Because it was 2. We did that. So let's put in the 1. You put in the 1, you get 2 minus 4 plus 1. Because put in a 1 there, put in a 1 there. And 2 minus 4 is negative 2, be negative 1. Put in the 3. I'm just going to mark those out. Put in the 3. That's 2 minus, put in 3 there, it's a 12. Put in 3 there, it's 9. 2 minus 12 is negative 10, plus 9 is negative 1. And put in the 4. Put in 4. So it's 2 minus, put in a 4, 16, plus 4 squared, 16, and you get 2. If we graph those, we have this, 0, 2. We have this, 1, negative 1. We have this, 2, negative 2. We have this, 3, negative 1. We have this, 4, 2. And we get the same exact parabola we got before. But that wasn't the real reason I had you do this, or I wanted to do this with you. I want you to look at these. What happens, and what we'll see here, is we start getting this peak and repeat, because we get this point, and we get its point across the axis of symmetry, and we'd have to fold over there and hit that. So for every point here up to, we have to have another point over here up to. And for every point here down 1, we have to have another point over here down 1. And that's neat how that works. And as we look at those, it closes in on the vertex. That's pretty neat. We'll see how that works and helps us in other ways as we go along as well. So it says use the information to graph. We've already graphed it twice, so I think we're pretty good on that one. But you can see our first graph, our second graph lines up with this graph. We did good. All right, so let me put this in different form for us so we can kind of see it all at once. So kind of the bigger picture then is we have this form is quadratic, and these graphs are parabolas. They'll either open up or they'll open down. If they open up like this one does, there's gonna be a minimum point at the vertex. If they were to open down, right, then there'll be a maximum point at the top of the vertex, or at the top where the vertex is. The y-intercept is always C. I don't know if you noticed that a while ago, but if that's 0 and that's 0, then the y-intercept's at C. That's a pretty good piece of information. The axis of symmetry is negative b over 2a. And then the domain and range. The domain is pretty much always all reals in all of our graphing. Oh, there's exceptions, but it's for sure all reals here with quadratics. The range, that depends, because if you got a maximum or minimum, that's going to be the thing that affects the range. So the range is going to be limited. It only comes down so far. Or if it's an open up, it only goes up so far. I mean, that's just how it works. So it says, find the vertex of the following equations. We're not going to do all of these, but we might as well do a couple of them. Find the vertex. Well, remember, the vertex is an xy point, and the x is the same as the axis of symmetry, which is negative b over 2a. So that's going to be real easy for us to find, I think, because we see that b is 6, so that's negative 6, and a is 1, so that's 2. So the x value of the axis of symmetry is 3. That being known, then we have 3 squared, which is 9. We have a minus 18 and a plus 9. And so lo and behold, the vertex is here. So if I graph that at negative 3, 0, that's going to be the vertex, the bottom, right? And so then also know that the y-intercept's at 9, because that's 0, then that's 9. So it's going to be up here. And so I can graph that like really, really quickly because I know just a little bit of stuff. That's pretty cool. Let's drop down and do this one. And let's say, okay, we know the axis of symmetry is negative b over 2a. B is 5, so negative b is negative 5. And 2a, since a is 2, that's 4. So it's a negative 5/4. Now if you prefer, you could look at that, negative 5/4. You could look at that as a decimal, negative 1.25. And then you've got to put the negative 1.25 back in here to find out this y value. If you have a great calculator, that would be easy to do. But that's how this works. That's how you find the vertex. Okay, let's move along. It says consider the quadratic function, Find the y-intercept, equation of the axis of symmetry, and the x-coordinate of the vertex. The easiest thing in the world to find is the y-intercept. It's 3. Because that's what happens when this is 0 and this is 0. And that's what happens at every y-intercept, x is 0. So y is 3. So this has a correct y-intercept. This does not. This has a correct y-intercept. This does not. So immediately I'm able to throw out 2 of the possibilities in my multiple choice. So the y-intercept is easy to find. The axis of symmetry is negative b over 2a. So let's do that. It's x equal negative b over 2a. You're going to need to become friends with this little dinky formula for finding the axis of symmetry, which is also the x of the vertex. For us, watch out. The linear term has the b, so it's a negative 6, so that makes that a positive 6. And then 2 times a is 1, so it's 3. So the axis of symmetry is 3. That's not true, and that is true. And so that's, if it's the axis of symmetry, it's also the x-coordinate of the vertex. So the answer is C. Then I can take that and put a couple of pieces of information together and graph it real easily. Just knowing a few things is so helpful. Consider the quadratic function this. This is the one we just did. It says make a table value that includes the vertex. Well, let's go back and remember that the vertex has an x-coordinate of 3, okay? X-coordinate of 3. We didn't discuss what would happen because they've got 3 here all the way down. We didn't discuss what would happen when this is 3, let's do. So this is 3, if that's 3, that's minus 18. If that's 3 squared, that's 9. And that's 12 minus 18 is negative 6. So, no, 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 yes. Now what I can do is go in, oh, and by the way, we know that 0, 3 is the y-intercept. So yes. If I want to, I can put in others of these and confirm them. I can confirm them. The thing that I would point out to you is notice how that these two fellows peat and repeat, these two fellows peat and repeat, because they're narrowing in on the vertex, closing in on the vertex. But when you think of what a parabola does, whether you're coming from this side or coming from this side, they're closing in on the vertex. It's just how it works. So our answer was D, as we saw. All right, consider the quadratic function da-da-da-da-da. That's the one we just did, same. And we already know that the y-intercept's at 3, so we go good, bad, bad, bad. The answer's A. Now, we did do some additional things. I hope it's A. Yeah. We did do some additional things when we did the previous parts to this. So we knew the name of the vertex, we knew where it was, we knew some other points. We could easily graph that from the graph, or from the chart, the table that we just had. So again, I'm reminding you of this stuff that we've talked about over and over already in just these few minutes. But just to note, if it opens up, it's got a minimum to open. If it opens down, it has a maximum. That's a minimum value and a maximum value. Pay attention. There is a minimum point and a minimum value. A point has an X and a Y. A value is just the Y. How low can it go on the Y? Maximum point has an X and a Y. Maximum value is just the Y coordinate of the point. So you've got to watch what you're being asked. Sometimes they'll ask for the maximum value, sometimes they'll ask for the maximum point or minimum, whichever. So just be aware of that difference. Consider the function da-da-da-da-da. Determine whether the function has a maximum or a minimum value. Well, you may remember from your Algebra 1 that if A is negative, it opens down. And if it opens down, young people, there's a maximum point and a maximum value. Done. Like I could do stuff, other stuff, I could work my way through. Since A is negative, less than 0, it opens down, has a maximum value. I could actually graph it, so I'm saying. I could actually do other stuff, but there's no real need for that then. It says consider this, state the maximum or minimum value. Okay, so we know there is a maximum because A is negative, it means it opens down, so we know there is a maximum point. What is the maximum value? So we know we're not even looking for a minimum because we already know there's a maximum. So we're looking for the maximum value. So the maximum value occurs at the maximum point, which is the vertex. Am I clear on that? The top of the parabola is the vertex, which is the max point, and it contains the max value as the y. Is that kind of clear? Okay. So let's talk about how would you find the maximum point, the vertex. We just did vertex a few minutes ago in a slide. We did a couple of them. And we said, well, we can find the x coordinate using the axis of symmetry formula. Because the axis of symmetry is x equals some number, and that x is also the x of the vertex. Aha. See in the big picture, see in the big picture, see in the big picture. So we look at this, b is 2, so the opposite of b is negative 2. And 2 times a, since a is negative 1, then that's negative 2, so it's 1. So this point right here, the x is 1. If I knew the y, then I know the maximum value, and that's what they're asking me for here. How do I find the y? Put 1 in and find out. What is 1 squared? 1. So I got negative 1. Because the negative had nothing to do with the square. It was just saying the opposite of x squared. So it's negative 1. Put in the 1 here, get plus 2 and plus 3. And what is negative 1 plus 2 plus 3? It is 4. That is, 4 is the max value. You know, I could talk about the axis of symmetry being 1 because it has to go through here. Lots of things I could do, but this is the answer to the question. 4 is the max value. The max point was 1, 4. 4 is the max value. So when I start talking about the domain, it's all reals. The range is going to be, let me just make this quick way. The range is y that is less than or equal to 4. Because 4 is as high as it can go, and it starts coming back down again. Range, that's the limit on the range. We'll see this shortly. So the max value is 4. And there it is. So I got ahead of myself. The domain I already said is all reals. The range I've already said is y is less than or equal to 4 because we had that. It was the max value at 1, 4. Our max point at 1, 4. The max value was 4. So that's as high as it can go. It's as high as it can go. So the domain's all reals and the range is limited to this. They write it cuter than I did. Let's see how they wrote it. The domain is all reals. They wrote it as a set. And the range is f of x such that f of x is less than or equal to 4. We know that we sometimes substitute y for f of x. We sometimes substitute f of x for y. So that shouldn't be too weird for you there. But we had, for all intent and purposes, we had the heart of what was written here. We just didn't write it as cute. Determine whether the function has a maximum minimum value. Since a is positive, it opens up, which means it has a minimum point and a minimum value, b. What is the minimum? Because it says maximum minimum, we already know is a minimum. What is the minimum? Well, remember the minimum occurs at the vertex, okay? Minimum occurs at the vertex. So vertex is the minimum point, the y is the minimum value. So if I knew the vertex, I'd be in business. How do I find the vertex? Well, probably what I could do is find the axis of symmetry, which gives me the x of the vertex. You see how we keep doing the same thing over here? So it's opposite of 4 and 2 times a, which is 1. So the axis of symmetry, you know, if we're looking at the graph, the axis of symmetry is over here at negative 2. And somewhere on that axis of symmetry lives the vertex. That's how it works. I mean, that's how it works. And what happens when x is negative 2? Well, that would be 4. That would be minus 8, and then minus 1. What is 4 minus 8 minus 1? Negative 5. So what is the minimum value? Negative 5. The y value of the minimum point is the minimum value. So same function, talking about the domain and range. So let me go back and let's just remind ourselves that the vertex is at negative 2, negative 5. The vertex is at negative 2, oops, it's over here. Get that. Vertex is at negative 2, negative 5. And we said the axis of symmetry right there, okay? So if that's where the vertex is at negative 2, negative 5, that's the minimum point. As low as it can go, it's going to do something like that, which I should have gotten it through here because we can see that the y-intercept's at negative 1, so that would have made it a little more, that's better, sort of. Okay, but the domain, all reals, and the range is limited because it can only come down to negative 5 and go back up. So it's got to be greater than or equal to negative 5 for the range, and that is answer A. Okay, I believe that is going to do some calculator stuff that we used to do.